In a previous video, we walked through Blinky Verilog design. In this video, we'll enhance that by adding an APB interface. And this allows the Blinky to be controlled by a processor, such as an ARM processor or a RISC-V processor. And the reason I want to do that is in preparation for my next project, which is right here, the Beagle V Fire. So I just got that. It's got 5 RISC processors on it, and it's got fabric connected to it by an APB bus. So hopefully if I can get a nice simulation working for my Blinky block, I can then put it into the fabric and make a light blink. Woohoo! So um, in order to do that, we have to know what an APB bus is. So that came out of the ARM world. And APB, I believe, stands for Advanced, of course, something good, um, Peripheral Bus. It's a pretty straightforward protocol. You can download it here. I've downloaded it already. Um, it's got 48 pages of description, probably 46 pages of cruft, and 2 pages that are useful. So let's look at those 2 useful pages. So here is the write transfer. And so on a write transfer, so it's a 2-stage transfer. On the first stage, everything gets set up. On the second stage, this enable pulses for 1 clock cycle. And that's it. So in the first stage, you set up the address. It's a memory mapped address. Every register, every variable has a different location, a memory address. You set the write strobe high. You set the p-select high. Um, you set the enable, well, so it's low in the first stage, but you set the data high. So the data value you want to write, it's a 32-bit data bus. And then on the second stage, you pulse the enable. And that pulse will capture the logic, will latch the logic into the Blinky block. They have a ready strobe here. In my designs, I always keep the ready high all the time, so I don't pulse it. The purpose of the ready is to be able to extend this if the Blinky block was slow or your peripheral block is slow. I would say very, very rarely, if ever, you need to extend. 2 cycles is plenty. Keep ready high. If you can follow that rule, you're going to win. Yeah. So that's a right strobe. It's just simple, right? Set everything up first cycle, pulse the enable on the second cycle. Done. Now let's do a read transfer. So click over here. Very, very similar. Everything gets set up on the first stage, pulse the enable on the second stage, and when that enable pulses, the Blinky block will drive whatever data is being read. So right now I've just got 1 register that's getting read. But potentially there could be many registers if Blinky grows into some other super Blinky block. So anyway, and again, I keep the ready signal high all the time. Sometimes blocks might need to be a few extra cycles to complete an operation. I say that's a very rare occasion. I would strongly recommend to the designer to change it so that the design can always keep ready working, ready high. If it's not always high, then all of a sudden you get into this complicated state machines that many corner cases that have to be tested and will cause your design to be less reliable. So do your best to keep ready high all the time. And so those are the 2 operations, a read and a write. We will talk about in the next couple videos, we'll go through the Blinky Verilog code on how it responds to these signals and how it generates the read data and how that data that once it's getting written into it affects the blink rate. And we will also then, in probably a subsequent video, talk about the test bench and how we do the APB writes or emulate the APB writes and emulate the APB reads that a processor would do. And I think that's it for this video.